This is Physical Science Laboratory number 9. It's going to involve composition of matter and chemical changes and give you an opportunity to look at percent yields and percent composition and different other factors. The material that we're going to be using in these studies is carbonates. The carbonate ion is CO3 2-. And in this experiment, I'm going to be giving you 3 different samples for you to determine the percent carbonate in. I'm actually going to be giving you the data for that. And what I want you to see, and I will work through specifically one of them so you can see how it would be done if you were doing it all yourself. And what you'll be doing is that you'll then be following up and completing the work on the other 2 samples. So, first of all, when a compound contains the carbonate ion is treated with acid, what happens is carbon dioxide is generated, right? We saw that before when we had vinegar added to baking soda, right? Carbon dioxide as a gas was lost. And so this is one of the gravimetric type of analyses where you can look at the weight or how much is lost in mass to determine what a given sample represents. So the whole thing is that if carbonate sample is decreased in mass by a certain amount, what that means is that because of the ratio of 1 mole of this to 1 mole of this in this reaction, and this is a balanced reaction, what the weight lost, which would be this material right here, means that you had that much weight here. Now, the weight of this particular ion is 60.01 grams per mole. The weight of this one is 44.01 grams per mole. So again, you have to work with the relative mass, molar masses of those 2 to determine how much you get. So if you had, for example, 44.01 grams of this released, you would know that you would have 60.01 grams of this must have been present in the initial material. So anyway, we'll continue, and I've got some fairly accurate numbers here. So here what we have is the mass of your tube, beaker, and HCl. Okay, so that's what these individual ones weigh. The combined weight of all of these is going to be 9.7821. That's 9.8721 grams. Okay, now that's just what those weigh. When you add the sample to that, the new weight is going to be 10.2758. Okay? So that's the beaker plus this right here. So what this means, you can subtract this first number from this one to give you the mass of the carbonate sample. Okay? The mass of that sample is going to be 0.4937 grams. Okay? I'm leaving the grams off. I did leave it off there. I will add it to these. Just want to make, because you know scientists always have to have the units. So the mass of the beaker and the sample after the reaction. So once you, what happened is you had the tube containing HCl was was next to this mass of the beaker, and then this beaker right here, we added to it the sample. Now what we're going to do is we're going to take that tube of HCl, we're going to add it to this beaker filled with that. Okay, we're going to put that tube back on there, but you now have a solution in the beaker, an empty test tube, and you've had a mass of gas coming off here. Okay, so the mass of the tube and the beaker, the tube, and the sample after the reaction gives you 10.0536, okay, grams, of course. So what that means is the difference between these two is the mass of the carbon dioxide that was evolved, doesn't it? And so the value here is going to be 0.2222 grams. Okay? So this is the data for this one. Okay, now we'll fill in what the data is on these. This is 9.8835 for this one. For here, it is 10.3792. Again, grams on each one of these, right? And after the reaction, it was 10.1561 grams. Excuse me. And for the third trial, this was 9.664 grams. Once we added the sample, it was 10.1667 grams. And after the reaction, it was 9.941 grams. You can fill out these right here for what the mass of the difference between these two will be your mass of your carbonate sample. The difference between these two will be the mass of the carbon dioxide evolved. The difference between these two will be your mass of your carbonate sample. The difference between these two will be the mass of the carbon dioxide evolved. So what's the percent carbonate in this experiment? Now, further down, what they do is they show you how you calculate the different matters, the different ones, okay? So what you would do for the percent carbonate experimental is you would multiply this by the molecular weight of the carbonate divided by the molecular weight of the carbon dioxide, okay? And so what you would end up with here is 0.3030 when you do that calculation, right? So you're multiplying this number by the molecular weight of the carbonate divided by the molecular weight of the carbon dioxide. Same sort of thing that we did during your problems that you worked on for this last week. Okay, what's your percent carbonate average? Okay, so what you're doing here is you're taking this number right here and you're dividing it by your carbonate sample, right? And then you're multiplying that by 100%. So your percent carbonate is this number divided the mass of the entire sample times 100. And so that is going to be 61.35%. Okay? Okay, and then what you're going to be doing is for the difference here, you'll be seeing what is the difference between these three numbers right here, okay? So you're going to take these three, add them together, and then get an average for them. And you'll use that to calculate differences and deviation and all of that, okay? So you've averaged these, okay, and that will allow you to then solve for these as well, so you can calculate all of those. And then following all of that, what you can then do is go on and get the deviations, the average deviations, the summary results, and then you can observe these different ones. Okay. Now, your observation here on this one, I'll give you a clue about this one. Essentially, what happened is you added a liquid, the HCl solution, to a solid sodium bicarbonate, right? And so what happened is you had the little bubbles all being generated, so that indicates a chemical, not a physical change, right? Also, it heated up. If you would have touched the beaker, you'd have seen it would have been a higher temperature. So that was two different things that indicate that it was a chemical, not a physical change. Then you can answer the rest of these questions. And that will be it for your lab for this week. I'll look forward to receiving those along with your problems at the beginning of class next week.